Okay guys, we're going to start talking about the definition of a one-sided limit. We just defined a regular limit, but if you recall, a one-sided limit is something we talked about in our first video. So it's actually right here, the limit as x approaches c from the right side of f of x equals L. What that means is x gets closer and closer to c only from the right side, f of x will get closer and closer to L. So I'm going to read off this definition, and you're going to see a few differences between this and the last definition. Let f be a function defined on an open interval containing c or having c as an endpoint. So in this case, c can actually be the endpoint of the open interval. It doesn't have to be inside it. And let L be a real number. The statement, limit as x approaches c from the right side, that's what that plus sign means, of f of x equals L, means that for each epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than x minus c is less than delta, you'll notice we don't have the absolute values there. Then the absolute value of f of x minus L is less than epsilon. So I'm going to draw a graph, and hopefully this will kind of show why this is a one-sided limit and how it is different from the two-sided limits we just looked at. So this is going to be my x-axis, and this is going to be my y-axis. Here's my function f of x. So if you'll notice what we're saying in this case, if this is my c value right about here, and I can draw up and say, let's say I want to prove that this is my L value, but I want to look at the limit as x approaches c from the right side. So I'm only looking at x values that are coming in from this right side just like that. Now, what I want to do is show that for any for any epsilon greater than 0, there exists a delta greater than 0, such that if this statement is true, then this statement is true. Well, what does this statement mean? If you look at this, x minus c has to be less than delta. So that lets us know that we're looking at x values sort of like this. A one-sided interval, if you will, where this is c plus delta. So we're looking at x values right in here, inside this interval between c and c plus delta. And we should be able to find a delta value such that given any epsilon value, this is still an interval around both sides of L, given any epsilon value, we'll be able to find a corresponding delta value such that all the f of x values that we get from x values inside that interval defined by c, in between c and c plus delta, I should say, all those x values will give us f of x values around the interval, in the interval around L, defined by the size of epsilon. And this makes sense because what we want to show is that as x is getting closer and closer to c from our right side, that f of x is getting closer and closer to L. So it makes sense that if that was to be true, we could pick any interval around L as small as we wanted, and as long as we got close to c from our right side, we would be able to find f of x values that fall in that interval. So that's what the one-sided limit is from the right. How could we maybe define this from the left? It turns out that it's not that big of a difference. We're just going to change our notation here to indicate that it's from the left, and the only other thing we have to do is change this inequality to say c minus x. And what that ends up doing is it ends up changing the direction from which the x values are coming, which is exactly what we want to do. So now instead of looking at the interval between c and c plus delta, we're actually looking at the interval between c and this, which is c minus delta. So now we're seeing if given any epsilon values, we can find a delta value that defines an interval between c minus delta and c, such that if we pick any x values in that interval, we'll get back f of x values in an interval around L, defined by epsilon. And that should also make sense. We're trying to show that as x gets closer and closer to c from the left side, only from the left side, we're not looking at the right side, that f of x is getting closer and closer to L. So those are our definitions for one-sided limits. In a later video, we're going to show you how one-sided limits and two-sided limits, or I should say the entire limit, how those two things are related.